Hey guys, so I'm going to go over the climate worksheet. Biggest thing that I saw when I was going through everyone's responses was one, we did actually a really good job, so I'm really proud of you for that. Two, the biggest issue that I noticed was for people who weren't necessarily getting a lot of correct answers, it was definitely because you looked up the answers from Google. Like I said during the school year, if you look up the answers from Google, it's not necessarily that they're going to be wrong. It is just very possible that they're going to use different words that you will not be seeing on the quiz or the test. So it's not going to be of your best interest to use Google to help you find the answers. Instead, I know it could be sometimes a pain to look through all the slides, but that is your best bet. So you'll notice that on some of the comments that I left, people, it is obvious that you use Google. I ask that you go back, look through the notes, see if you can use the proper vocabulary and kind of ways that were worded in the notes, because that's what you're going to see on the quiz or the test. And then we'll go through each other question and kind of talk about common errors that people made, etc. So the first one is, what is climate and how does it usually change? So everyone did really well with this first part. Climate is the long-term average of weather over time in a particular spot. Most people got that. One thing that people did not get very frequently is that climate changes slowly. That is important. Some people said, like, literally how it changes, like wind changes it, water changes it. Just in terms of time, it usually changes slowly. So that's important, especially when we're differentiating between weather. Weather happens very quickly, day to day. Climate is a long-term average, and normally it changes slowly. All right, number 2, how does latitude affect climate? Again, we did pretty well. Basically, as long as you mention that different amounts of sunlight are received at different latitudes, that's how it heats the earth differently. So that's all we need for number 2. Number 3 was, what are the 3 latitude climate zones and describe them? So most people did pretty well on this one. The biggest thing that I noticed was, again, if you use Google, sometimes instead of saying the polar zone, you put the Arctic zone. Just get into the habit of using polar because that refers to the North and the South Pole, whereas the Arctic is just referring to one of the poles. And another thing that I noticed was that people were giving one or the other when it comes to like descriptions of them. So when you're describing these latitude or climate zones, you should be describing the temperature that they have, and you should also be describing the amount of sunlight. So I noticed that a lot of people were giving one or the other. If you look in here, it says the polar zone receives the least amount of sunlight and is therefore the coldest. The tropics receive the most sunlight and are the warmest. The temperate zones are in between, and they kind of get medium temperatures as well as amounts of sunlight. So remember, give the temperature and the sunlight. And another thing is, for the temperate zone, it's kind of a weird zone. It's in between the two. If you just want to say medium sunlight, medium temperatures, that is A-okay. All right, for number 4, this one was pretty straightforward. Basically, it makes kind of like a sandwich. So the polar zone is your bread. Your temperate zone is like your condiments, lettuce, tomato, whatever you put on your burger. And tropic zone is the actual burger itself. Remember, there is technically 2 tropic zones, but since they're on either side of an imaginary equator, we kind of lump it together as one big one. All right, number 5. Again, people did pretty well with this. This is just keep it super simple. How is wind created? Think about the physics of it. In order for air to move, because that's wind, when air moves, the only basic thing that we need is a change in pressure. So it's when high pressure goes to low pressure. That's what makes wind. Super simple. A lot of you got into like the background of what causes an area of high pressure versus low pressure. If we just want to know how is wind created, when high pressure moves to low pressure. Simple, easy, to the point. All right, so this next one, how does wind affect the climate? This is like, there's two really, really big questions for the climate lesson. How does wind affect the climate? And how does water affect the climate? So this is one of them. Remember, when you're answering these questions, you only need to choose one of these. Now, I have three listed. I have the temperature, I have cloud coverage, and we also have humidity and precipitation. You only need to choose one of these. You don't need to do all three, just one. But when you choose one of them, you have to explain it. And I noticed that if people got to this step, which was good, they forgot to explain it. Some of you obviously did great, perfect, wonderful, but the most common error I saw was you chose one of them but forgot to explain. So if you're stuck and you're like, all right, well, I know it can affect the temperature, but I don't remember how, go back to this resource page. It's uploaded on Classroom, open it up, scroll down, boom, here are your answers. Okay, it talks about how wind affects the climate. Well, it can change the temperature, the cloud coverage, or the humidity and precipitation. And the explanation is under each one. So if we wanted to say temperature, wind will affect the temperature. Air from the polar region, which is cooler and high pressure, rushes into the tropics, making it cooler than before. That's all you need. If you wanted to choose cloud coverage, you could say when cooler air from the poles pushes warm air from the tropics upwards, it will cool and condense and form clouds. Done. Simple, to the point. So I'll kind of highlight the areas where temperature is talked about. So wind can affect the temperature. Wind can change the temperature as air from the poles, which is cooler and high pressure, rushes towards the tropics, making the area cooler. Okay? That's all you would need for temperature. So all of the yellow, if you chose temperature, you only need the yellow stuff. If you chose cloud coverage, you would need all the green stuff. Wind can change the cloud coverage when air crashes in the tropics and gets pushed up into the atmosphere, where it cools, condenses, and forms a cloud. There you go. That's for cloud coverage. And if you wanted to talk about humidity and precipitation, you would need this explanation. If enough form, it can be more rainy in the area, usually in the tropics. Okay, and I even drew a little picture. Shows how air is coming in from the poles, it crashes, moves up, makes clouds and rain. Okay, so again, you choose one of these and then give the explanation that matches. So for temperature, it's all the yellow stuff. If you want to choose cloud coverage, you talk about the green stuff. And if you want to choose humidity and precipitation, talk about the purple. All right, so hopefully that kind of clears things up on how wind can affect the climate. And if you look too, all this is saying is this same exact thing that's written here. Wind, humidity, precipitation. If there are more clouds in areas that are more windy, those areas are more likely to experience rain. If enough clouds form, it can be more rainy in the area, usually in the tropics. There you go. So it's pretty much the same thing if you go back to that climate resource document. All right, so that's number 6. Number 7, how does the Coriolis effect change wind patterns? This is, again, pretty straightforward. Most people got this. Basically, it will cause the wind to curve its original path. Okay, so it's just not going to go exactly where it should be going because the Earth is rotating. And then another thing that some people did was they flipped the way that it spins. So in the northern hemisphere, we go counterclockwise. I always like to think back to that crazy girl who, when we did the high and low pressure systems, that girl from El Paso, Texas, and she went, high pressure, it was counterclock, that crazy girl. She's in El Paso, that's Texas. If it goes counterclockwise, that would be the northern hemisphere, okay? Then the southern hemisphere is going to go clockwise, okay? And again, Earth's rotation causes the Coriolis effect. A lot of people just forgot to put that in there too. All right, so that's number 7. Number 8, we have what is unique about water's heating abilities that allows land and sea breezes to occur. This just has to deal with a property of water, and that's that water takes a long time to heat up and then retains its heat for a while. So it stays hot for a while. Land, on the other hand, will heat faster and cool down quicker. That's the difference. Okay, it's not asking about how land and sea breezes happen. It's just asking what is unique about water's heating abilities. So it takes a long time to heat up, but then it stays hot for a while. All right, number 9, what two properties of salt water could affect density? Water's temperature and salinity could affect density. I've had a lot of people saying temperature and depth, but the more appropriate answer would be temperature and salinity. Remember that salinity means the amount of salt in the water. Okay, so if it's more salty, it is going to be more likely to sink. So salinity, amount of salt in water. Ta-da! All right, so cold water that is high in salinity is going to be the densest of the water. So colder water, high salinity, or more salt is more likely to be dense. All right, so this final one of the written ones is the other $1 million question. So remember, I said number 6 was super important, where it's talking about how can wind affect the climate. Ooh, I don't want that shape. Get out of here. I want a circle. Where it's talking about how wind can affect the climate. That is pretty important. We also want to talk about number 10. That's another really important one. How does water affect the climate? Now, sometimes you'll see it as oceanic circulation. That's just water. So, same thing with the wind. If you're not sure, look at the climate resources document. If you look at water can affect the wind of an area. Water could affect the cloud coverage of an area. Water could affect the humidity of an area, or water could affect the temperature of an area. All you need to do is choose one of these 4 and explain it. Whatever one you choose. You don't have to do all of it, just one explanation. So over here, I'm going to highlight, and we'll do the same thing we did for the water, for the wind. So water can change the wind. It could change the cloud coverage. It could change the humidity, or it could change the temperature of an area. So let's go over wind. A coastal area could be windier than normal if sea breezes occur. Done. Okay? That's for wind. If you're near water, it could have an effect on the wind of the area because sea breezes will occur and it will be windier than normal. Done. If you want to go the cloud coverage route, you could say that water can change cloud coverage because a sea breeze can cause clouds to form when cool air pushes warm air over land up into the atmosphere. Then the air will cool and condense into clouds. Done. Okay, that's for cloud coverage, if that's the route you want to take. If you want to say that water can change the humidity of an area, that's fine as well. You can say that water can change the humidity of an area because an area can be humid near the coast because more water is present to be evaporated. Done. If you want to go the temperature route, you can say, finally, water can keep coastal areas cooler or warmer depending on the season or temperature of the water. Now, an important part is try and give me like a example of how it could keep it cooler or warmer, and that's listed over here on the climate resources. So if you go water, temperature, water can keep coastal areas cooler than normal in the spring because water takes so long to heat up, and by the time spring is around, the water's still cold from winter. It also keeps coastal areas warmer in the fall because it takes longer to cool down, and at that point, the water has had all summer to heat up. So that's something else that you would want to put into your response if you chose the temperature route. Okay? So there we go. Then for number 11, this one is really tough. I apologize. Normally, if we were in regular school, you would have it on paper and you can just draw it in real nice and easy. So if you did it on paper, great. If you had a really difficult. I'm sorry about that. But I'll just show you kind of what it looks like. This isn't necessarily going to be on the quiz or the test. It's just good to kind of put it all together visually. So this is kind of what I did or I was looking for. Basically, you need to label the polar zones, so polar zones and tropic zones. So we got that out of the way. Polar zone, tropic zones. All right, cold air. Well, I think to myself, where would cold air be? Probably in the polar zones. So instead of writing cold air, I just kind of made a big arrow and saying, all right, in these two areas, the polar zones, we're going to have cold air. Okay, so that's done. Where am I likely to have warm air? Oh, it's probably going to be in the tropic zones right there. So again, I kind of made a little arrow and said warm air here. Done. High pressure. Well, I know that cold and high pressure go together. So where do I have my cold air? Here. High pressure is going to be in the polar region. And that means that low pressure is going to be in the tropic zones because warm and low pressure go together. So clouds, where am I more likely to find clouds? Well, if we remember how air goes from the polar zone to the tropics, it pushes the air upwards. It's lower pressure, more likely to have clouds and rain in the tropic zone. So there's that. Whoop. And then we have dry air and sunny skies. Well, if I think, dry air, sunny skies, that sounds like a low pressure system. Sorry, a high pressure system. Where am I likely to have high pressure? In the polar zones. So dry air, sunny skies. And then finally, winds move clockwise, winds move counterclockwise. So winds move counterclockwise is in the northern hemisphere, so as long as you put it anywhere up here. And then winds move counterclockwise would be down here in the southern hemisphere. And then finally, for number 12, create a diagram that shows how ocean currents are created. Really, you just need to show that movement of the water, how cold, dense, high salinity water sinks and moves down that way, and warm water takes its place. That's all we need to know, is that water is moving because cold and salty water sinks and warm water takes its place. Cold water sinks, warm water takes its place, cold water sinks, and that's what makes the cycle. All right, that pretty much explains it all. I think I'll save a version of this and I'll kind of say like annotated climate worksheet key for those of you who want to see this, if this highlighted area makes it easier for you. But that's it. I'll be holding a Zoom meeting for you if you have any more questions. Our quiz is going to be on Friday. But pretty much if you study this worksheet, you're going to be good to go. Again, the diagram, don't worry about it too much. It's just a nice visual to kind of keep in mind where cold air, high pressure, dry air, sunny skies would be, and where tropic zone is going to be kind of like the nastier clouds, rain, that kind of deal. Warm, but going to be a little bit more cloudy and rainy. Think, rainforests. And same thing with this. Good to know, but won't be required for the quiz or test. This stuff, especially number 10, especially number 6, is going to be really important. So, again, if you have any questions, let me know. I'll be happy to answer them. Other than that, I'll chat with you later.